Okay, good evening to all. Today we will be discussing the basics of database management system. We'll be mostly covering theoretical part, and practical part we'll be covering later with hands-on with MySQL. Today's session we will be mostly covering the foundations or fundamentals required for understanding the subject of database. Usually this is taken to be like a complex subject. That is mostly because some of the theory may be confusing when you are trying to learn it for the first time. So I will try to break it down into suitable modules, and I will try to simplify explanations as much as possible so that you will get the concepts. Once you get the concepts, it will be very easy for you to implement once you start doing it. SQL hands-on and all, even NoSQL systems. So we will start with the basics and foundations. So basically I will be referring Silver Shas, which is a standard textbook given as our reference also. Mainly, actually they have a full set of presentations available in their site as well. So that slides only I will be using mostly. And I will be just updating here and there and adding more points or modifying so that the points are maybe more easy to understand. And the second thing is another nice book. It's a bit old book written by Coronel and Morris. It's also very nice diagrams, illustrations and all. Then IGNO study material for MCS 2343. So these things also, and images I will be using throughout, which I have taken from Google search. So this first 2-3 materials you can go through. If you need to go in any of the topics cover that we are covering, if you need to go in more detail, you can have a look at these references. So we will see what is a database system. So usually when we refer to database system, DBMS, database management system, all these actually refer to the same thing. Shortly we will see what is a database and all. So first we will see what is a database system. When we refer to the word database system, what that means. So it is basically it contains in our enterprise thing. If we consider the DBMS contains information about a particular enterprise. The enterprise here can be a company, it can be a like a school, course, university, whatever you want. An enterprise here can be anything. So it basically what all are contained in a database management system, a collection of interrelated data. So not just data, there is some relations existing between data as well. And a set of programs to access the data. So we will have a like similar to application program kind of things that will allow us to interact with this data, and an environment which helps us to integrate this data and this set of programs. And the environment has to be convenient as well as efficient. So all the collection of all these things we will call as a database management system, DBMS, etc. And mostly the collections of data that DBMS manages are highly valuable, relatively large. See the word relatively large here. If the data is very large, the database systems we will use mostly NoSQL systems and now recently. But normal our SQL databases based database as we see are will work pretty fine for relatively large data sets. So a choice of how big the data set is one factor which will decide whether I go for an SQL or a NoSQL DBMS. And another thing is that it needs to be accessed by multiple users and applications often at the same time. Like if there is a university database and today the results are being announced, all the students from that university will try to log into the system, and all the marks will be stored in the database only. So that should support maybe 1,000 or 10,000 or depending on the university or 1 lakh people to log in at the same time and see their marks. And at the same time, some teachers also might be interested to know the performance of their students. So they should get another view of the same results where irrespective of individual people, a total or overall statistics kind of thing is available to them. So all these should be accessible or at the same time. Yeah, if you have some doubt, you can ask here. Okay. And the modern database system, as we call it, are mostly complex software systems which will be managing large complex collection of data. So we will go to some history also. So before these databases were actually there, so how we used to manage similar things. So suppose you assume like there are students joining a university. So we will put maybe one folder corresponding to each student. So maybe 100 students, each student will be having a folder. Inside that we will put his details like his previous 10 mark list, plus 2 mark list, his admission details, then his fee payment details, things like that. Now suppose now I need to have, suppose I have a bus pass requirement. So I need to know which all students are coming by bus. So if I put it inside each folder of student, that will be difficult for me to track. So I will have a keep a folder corresponding to whichever student is going by bus pass. And then inside that I will again repeat some of the information that is already in these files, like a student name, his address, where he is living, so that I can decide which all students need a bus in which all routes, things like that. Similarly, if I have some course details, again that course details, then students who are enrolled in that course, I will keep in a separate file. Because if I have inside the students, I keep that information, then each student's folder I will have to select or query to find out which all students are enrolled in a particular case. So this, as you can see, this leads like same data will needs to be replicated at different folders, and like students name and address will be there in this as well as this, and the students name as well as course details will be there in this as well as this. So like that, the same data will be there in different folders. Whereas if you consider the same scenario where like when we are trying to implement with a database system, we can have like a table which has the students, then address details, then fee details, whether they have they want a bus or not. So things like that I can put in a table, and that thing I can just query, so that with a single data table like structure, I can have whatever information that I had, which was distributed over this multiple types of folders. So these file-based systems were like the systems that were being commonly used. Now, initially it was in files, like physical files, right? In papers, printouts. Then when computers came, that changed to same mode, changed to files maintained in computers. So database systems came as a natural extension of that file-based systems. So as we told, this file-based system, data redundancy and inconsistency. Suppose I change one data here and I forgot to change that corresponding data in this folder, it will lead to like different data existing in different folders. So which is not correct. So things like that, and difficulty in accessing data. If I want to get some data corresponding to all students, I will have to see some 100 folders or 1000 folders. Then data isolation. There are multiple files which are in different formats. So it is very difficult to find the relations between data. And integrity problems, as we already saw. Each folder has some details which I need to process independently. So overall it is very cumbersome. When for 10 students I can maybe manage easily, but for 100 students, 1000 students, that will be very difficult. Then atomicity of updates. This means that suppose I am trying to edit in students folder as well as bus pass folder the detail address of one student, and once I edit in this file, the current went off or power went off. Then later when I put it on, this will be new data, whereas this will be old data. So things like that can happen when I am going for a file-based system. Then concurrent access by multiple users. So files, as we know, like it is residing in a server, or even then I provide an application program. It will be very difficult, like our earlier case where students are searching for their marks. It will be very difficult for 1000 people to like query this same file structure to find their corresponding marks. So that will have a bottleneck on the performance. And uncontrolled access will lead to inconsistencies. Like one person is trying to, like bus pass manager, somebody is trying to edit that, whereas course faculty is trying to edit this, and suppose their edits are like not matching to one another, then that will create more issues in storing the data. And it causes security problems also, since multiple users need to be like using the same data file. It is very difficult to control the access to the data. So basically all these issues are covered by the approach called DBMS that we discussed. So these all we saw. What are some of the disadvantages with a file-based system? So in order to overcome these, say database system emerged. So a database is a persistent. So the word persistent means that persistent with respect to type. So even if I don't do anything, the data will stay there. If I update something, then the updated data will be there. That way, persistent with respect to type. So once I make a change, that change will be permanent. That is what we mean by persistent here. Collection. So collection means that there is some set of data, a collection of data. Of what type of data is what is called logically related. Like I suppose in a course university details, if I put the data of types of animals in a zoo, those are not related, right? I need to put in that the details of the students and details of the courses, details of faculty. So the whatever contents of a database will be like logically related data. And a database has a self-describing nature, so which we'll be discussing shortly. This is implemented with something that is called a data dictionary. So the database needs to describe itself, that we need to have some mechanism whereby a database can tell I am having so and so tables and these are the type of data that I am holding. So for that, it needs to contain not only the data, but also the complete definition of the structure as well as constraints. Constraints here means like if I am having 100 students and I denote a unique ID to each student, or like considering the people Aadhaar number. So Aadhaar number needs to be unique for each person. So things like that I can implement using constraints. That means that I am constraining it to take some particular values only, or some particular meet some particular conditions, like mobile number needs to be 10 digits. Like some student cannot enter a mobile number of 5 digits. So that's a constraint. So then all these are stored in what is called a system catalog. And the DBMS software that we discussed, it manages all these things. And in addition, it allows data sharing and integration of all these different data, the definition of data, constraints, everything into a single database. So compared to file system that we saw earlier, once we come to this DBMS, as we saw, we don't have much redundancies because same data needs to be repeated at multiple places. We will have shared data. Multiple people can access it at the same time without affecting the security or the integrity of data. Data independence, like data of different students or different entities are independent of each other. I can access that independently. Improved integrity, that is the possibility that somebody edits the data and the data becomes corrupt is like minimized. Efficient data access, that means I will be able to query the data efficiently. Yeah, Nishant, atomicity I will be coming in detail later. Yeah, that time I will tell once again. Then multiple user interfaces. Like most of the things that we are seeing here, it is just a glimpse here. Each of these, how it is implemented in DBMS and all, we will be coming in detail for almost all of these when we cover different topics like transaction, concurrency. So they are corresponding how in a DBMS these things are implemented will come. Then multiple user interface, like I told, the students need to see the result. The instructor needs to see how his students performed in the exam. So he needs to have something like an average kind of view. So then representing complex relationship among data, improved security backup and recovery, support for concurrent transactions. So these kind of things are like standard descriptive type questions, or like when you are somebody is asked in an interview or something, what advantages you got when you implement DBMS. So these are all like not like technical questions, right? These are more from a implementation point of view or history point of view. But it is always best to know why you went for some particular design approach as you use it today, right? So then we will move to what is called a view of data. So as I told earlier, the students need to view their results once suppose today results are being announced, and the teacher needs to see the performance of his students. So basically these are different views of the data which is provided to different users. So as we told earlier, a database has a collection of interrelated data, and there will be a set of programs that will be provided which will allow users to access and modify this data. So, and one of the major purpose of database is that it should provide users with a view of the data. That is, each user should need to see data which is relevant to him. that if I am a student, then the details like the enrollment details, like fees, when he paid fees. It is only matters to me that I have paid the fees, or by what date I have to pay the fees. It does not matter to me that, okay, what date I paid the fees, did I pay fine and all? I need not see, right? So, but whereas from a university staff point of view, they need to find out, okay, how many people are yet to pay the fees, how many people have paid it with the late fees, how many people are paying it on time, things like that. So each, for the same data, each user needs to have his own curated abstract view of the data. So that is what we call the view of the data. And for example, if we consider an example here, suppose there is a bank department. It may have a loan department, accounts department, and a personal department. So personal department is interested only in the employees table. It needs to see what is employees, how much is their rating, how much they are earning, things like that. Whereas accounts department needs to have data about the current accounts as well as saving accounts, so that it can monitor them, the transactions from or to their accounts. And loan department needs to have access to maybe mortgage loans, installment loans, things like that, that corresponding database. Like loan department is not interested in what is there in the employees database, or accounts department, except for maybe paying salaries, it is not much interested in what is the contents of employees department. Similarly, the personal department is not at all concerned about what is the type of loans that the bank is giving and things like that. It is concerned only about employees. So corresponding to each user, we need to provide a view that is appropriate to that corresponding user, hiding all the other irrelevant information. And so for this, we define two terms here. One is data models and data abstraction. So data models means that a collection of conceptual tools for describing data, the relationship between data, how the data is existing, and the consistency constraints. So something that describes all these, like how you describe the data, the relationships, semantics, and consistency constraints, together we call as a data model. And we will be defining a data model corresponding to each application. For example, if you see this particular application here, it will have a data model which will have this tables like employees, current accounts, savings account, loans, two types, things like that. And data relationships, it will tell that, okay, accounts department needs to access this and this. So we will come into more detail of all these things when we learn about entity relationship models. So where you will get a more idea of how actually these things are implemented in a real database. And second thing term that we see here is abstract view, right? So that is related to data abstraction. So that, as I already told, you have to hide the complexity of data structures to represent data from users through several layers of data abstractions. So this may seem complex, but what it means that a user needs to view only the data that is relevant to him. All the other irrelevant data and the complex queries that are involved to get the data, the user need not be concerned about that. He's just concerned about whether he is getting the data that he wants. He is not concerned at all about the other data in the system.